Okay, so today we are going to look at the use of electromagnets. Now, just to remind you, an electromagnet is something that has a coil of wire plugged into a supply with an iron core in the middle of it. Okay, and that means when you switch on the power supply, it acts like a magnet. When you switch it off, it does not, no longer acts like a magnet. So, one application of electromagnets, or one use of electromagnets, is the electric bell. So this is what an electric bell looks like. Okay, so we have a power supply here. We've got our coil and our soft iron core here. So this is our electromagnet. Okay, so it can get turned on or off, depending on whether it's connected to the power supply. And this part here, the adjustable contact, is the thing that is responsible for determining whether it is plugged in or not. Because you can see here, that can sort of get separated or not. And if it's not attached to it, if it's not contacted, it's not on, or if it is contacted, it is on. Okay, we've also got a gong here, that's the thing that makes a noise, and a hammer here, which hits it and makes a noise. So what happens in an electric bell? So when the bell is connected to an electrical supply, and an electrical current flows through it. Get that pen. There we go. An electric current flows through the bell's electric circuit. So when that electric current flows through the coil, it produces a magnetic field. The steel hammer is then attracted to the coil and hits the gong, which vibrates, making a sound. So we'll just pause there and have a look back at the diagram. Hopefully we'll see a video of this as well. So when this is on, this gets connected, this gets attracted towards it, and we hear a sound. Okay. When the hammer is bent towards the gong, it's pulled away from the adjustable contact, breaking the circuit. When that happens, the electromagnet is then switched off and no longer attracts the hammer. Since the hammer is made of spring steel, it springs back towards the adjustable contact. This then completes the electric circuit again, and the whole process repeats, making the bell ring continuously. So basically, when it's attracted, it makes a noise. When it gets attracted towards the gong, it then breaks the circuit, so it goes back to its normal position. It's not hitting the gong, but then the circuit is complete again. So it gets attracted again, blah blah blah, attracted, not attracted, attracted, not attracted, over and over and over again. So it goes like a because it keeps going attracted or not. Another application is a relay. So a relay is something that uses a teeny tiny circuit to then switch on a bigger circuit. So for example, this circuit 1 here, circuit 1, is just an electromagnet. Okay, so when you turn that on, it attracts the iron rocker arm. So that gets attracted to there, which in turn makes that go slanted and get attracted to the contacts here. Okay, so when this gets turned on, this then pushes towards here and completes the circuit over here, which can turn on a motor or something else. So when the switch is closed, electric current flows in circuit 1, and the iron rocker arm is attracted to the electromagnet. This forces the contacts of circuit 2 together and completes the circuit. This allows a current to flow in circuit 2, and the motor switches on. A relay is used to operate the starter motor in cars. An electromagnet allows a small current in one circuit to control a large current in the circuit with the motor. And a loudspeaker. So with a loudspeaker, you have got an electromagnet that it's a little bit like the bell. Okay, so an electromagnet gets turned on and off continuously, and it attracts something that's magnetic here towards it, and then it turns off again, so it moves back. So the diaphragm of the loudspeaker moves back and forth continuously to make a sound. The wire from the amplifier carries an alternating current, which makes the coil and the paper cone move backwards and forwards at the same frequency as the changing current. The paper cone then moves the air backwards and forwards, which creates a sound. So basically what's happening is this part here keeps getting turned on and off again. Okay, and this gets attracted or not attracted, so it moves back and forth, which moves the diaphragm back and forth, and starts vibrating and making a noise. We also use them in recycling. So a large electromagnet is used on a recycling plant conveyor belt to pick up and move metal cans. Which metals would the electromagnet attract? Well, we know the magnetic materials are iron and steel, which is an alloy of iron, cobalt, and nickel. I'll put steel in brackets, but we know it's a type of iron. And what advantage does an electromagnet have over a permanent magnet? It can be switched on and off. Try that again. Be switched. My pen is not liking me today. Let's put can be switched on and off. Also, as another use here, maglev trains can use magnetic levitation. So basically what they do is they float to remove friction. And also, you don't need to know this, but if you are interested in physics, you can look up the electromagnets in particle accelerator, because they're really clever electromagnets. So I'm going to stop there, and I'm going to tell you what you are next.